Part C of solving trig functions with multiple angles. Here's our example. We want to solve for x from 0 to 2 pi. So we have the equation 3 times the tangent of x over 2. So I'm going to go ahead and throw in parentheses there. All right, let's go ahead and solve for x. So we solve by undoing. So we're going to first subtract 3 from both sides to remove the 3 from the left. So we get a negative. Then we're going to divide both sides by 3 to remove the multiplier of 3 in front of the equation. So we have negative 3 divided by 3. And now we just simplify. Negative 3 over 3 is negative 1. All right. Now, we're going to use our inverse trig. So we're going to say, notice this is x over 2. So we say x over 2 equals the tangent inverse of negative 1. Now we need to figure out where is there going to be a tangent of some angle giving us negative 1. Well, here is one set of ordered pairs. If you take the tangent of 7 pi over 4 and we divide the sine over the cosine, so negative square root of 2 over 2 divided by square root of 2 over 2 would give us negative 1. So there's one of them. And then same thing would hold true with 3 pi over 4. Would also give you the tangent being negative 1. Okay, so we say x over 2 equals our 3 pi over 4. And remember, the period for a tangent and a cotangent is not 2 pi n, but n pi. It's one period. And the other angle that we just found was 7 pi over 4 plus pi n. All right, now we're going to solve this for x. So to solve this for x, we have to get rid of this divider of 2. So to undo that, we're going to multiply everything by 2 on the right-hand side. So we say 3 pi over 4 times 2 plus 2 n pi and 7 pi over 4 times 2 plus 2 pi n. So we're multiplying everything by 2, all the terms on the right. Now let's simplify this. When we simplify this, we multiply across, so we get 6 pi over 4 plus 2 pi n and 14 pi over 4 plus 2 pi n. Now let's simplify. So we get x equals 3 pi over 2 plus 2 pi n. And then when we reduce this by a 2, we get 7 pi over 2 plus 2 pi n. Now, one of these answers is not going to hold true because we only want the solutions from 0 to 2 pi. 0 to 2 pi. So if we graph the first angle of 3 pi over 2, notice this would be pi over 2, 2 pi over 2, 3 pi over 2. Oh, that one works. It's in the first revolution. So this one's good, this solution. Now if we go more than one revolution around 2 pi n, we'd be outside the interval range. Now, let's try and graph 3 pi or 7 pi over 2. So we'll continue on. So this would be 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. Oh, we're outside the interval solution from 0 to 2 pi. So this one is too big. So we just have one solution. A solution for 3 pi over 2. All right. Now, solve for x for this one. Again, here's another one of those fun tangent problems. So we want to solve for x. So we're going to go ahead and solve by undoing. So we have to undo the squared. So to undo a squared and a tangent, we have to square root both sides. And don't forget the plus or minus. Now we're going to use our inverse trig. So I'm going to set up two equations. X equals, or not x, 3x equals the tangent inverse of a positive square root of 3. Leave some space. 3x equals the tangent inverse of negative square root of 3. All right, so let's talk about the positive square root of 3. Remember we spent some time in an earlier video finding the tangents of each of these? The tangent of this one equals positive 1. the tangent of this one equals square root of 3 over 3. And the tangent of this one equals square root of 3, pi over 3. So we know anytime we go around the unit circle and we divide the square root of 3 over 2 over 1/2, we're going to get square root of 3. Now it could be a plus or minus. Well, this one would be a tangent being a negative, square root of 3. This one right here would be a tangent being a positive, square root of 3. And then our last one, right here, 5 pi over 3, would give you a tangent being a negative, square root of 3. All right, so let's go ahead and find those solutions then. So for the first one here, we're going to find positive square root of 3 for our tangent. So we say pi over 3 is a positive, and 4 pi over 3 is a positive. So we say 3x equals 4 pi over 3 plus pi n and pi over 3 plus pi n. Remember, we have to get rid of this 3, so we're going to divide everything by 3, or multiply by 1/3. Alright, I wrote that purple stuff too big, so we'll continue on with this blue, and we'll do the negative in a little bit. So when I finish this blue simplification, we get x equals 4 pi over 9 plus pi over 3n, and pi over 9 plus pi over 3n. So here would be one solution. Here would be another solution. Now we'll go ahead and find 3x equals the tangent inverse of negative square root of 3. And these are our other two angles here, 5 pi over 3 and 2 pi over 3. So we say 3x equals, make sure I'm doing this right here, 2 pi over 3 and 5 pi over 3. So 2 pi over 3 plus pi n and 5 pi over 3 plus pi n. Now we'll divide everything by 3 or multiply by 1/3. So 2 pi over 3 times 1/3 plus pi over n divided by 3 plus 5 pi over 3 times 1/3 plus pi over n divided by 3. All right, we're almost there. So x equals 2 pi over 9 plus pi over 3n. So there's one of your solutions. And then the other one, 5 pi over 9 plus pi n, if you wanted it infinitely many, but we just want the first revolution. So there are your 4 solutions bubbled in: pi over n, 2 pi over n, 4 pi over n, and 5 pi over n.